Hello and welcome. Well, in our last video we introduced the concept of percents. We introduced really what percent means, and we described some of the basic systematic strategies for converting numbers from percents to non-percents, also non-percents over to percents. And we were dealing with percentage values that were decimals, that were fractions, that were whole numbers, just in the same way that in non-percents we sometimes deal with whole numbers, fractions, and decimals as well. So in each case we are multiplying or dividing by 100%, and that has different techniques when you're dealing with a decimal or with a fraction, but it's essentially the same thing, going back and forth here. We're going to extend that knowledge to the next video here, in which we apply the concept of percentages to a number of different problems and show you how you can use this a little bit more intensively than what we've done. In particular, I'm going to show you an example problem here which we won't solve now, but we'll solve later on in the video. And so right now I want you to think about how you would solve this based upon your present knowledge, or your knowledge as the video proceeds. John had a recent purchase for which the sales tax was $16.23. The sales tax rate in Fort Collins, Colorado is 6.25%. That's true for everything except food, where it's lower. What was the amount of the full purchase, assuming that none of this was food? So the sales tax rate would be 6.25%. So think about how you would solve that problem as we're proceeding on through this new content here. But before we do that, I want to start us off with a couple of warm-up problems here. We've got two numbers here that are not percents, and I'd like you to convert those to a percent. On the right-hand side, we have two numbers that are percents, and I'd like you to convert those back to being non-percents. Take some time to do that. Welcome back. Well, this serves as a pretty good review of the techniques and strategies that we talked about in the previous video here. On the left-hand side, we are converting 0.255 to a percent. That means we're multiplying it by 100%. That has the effect of moving the decimal point here 2 spaces to the right, so we have 25.5%. In the same way, if I can skip to the third one here, 32.78%, that's going from a percent to something that's not a percent, so we're doing the reverse of that. We're dividing it by 100%, which moves the decimal point 2 spaces now to the left. So 32.78% now becomes 0.3278. Now let's take a look at the fraction ones. And you might feel a little lost when it comes to the fractions, but just understand that it's the exact same technique as before. So for 3/250ths, how would you multiply that by 100%? Well, that's just 100% over 1, which means that across the top now we have 3 times 100, which is 300. We still have the 250 in the denominator, that didn't change. So now we have 300 250ths of a percent. So it's a little bit more than 1% here. We can reduce that fraction 300 over 250 by dividing top and bottom by 50, and we get 6/5 of a percent. So 1 1/5 percent, essentially, a little bit over 1%. In the same way, we can do the reverse of that with the last problem, 3 7/8 percent. Now we're converting from something that is a percent to something that's not a percent, so we do the reverse of that, where we multiply it not by 100 over 1, but by 1 over 100. Here we want to also convert that mixed number to an improper fraction. 3 times 8 is 24, plus 7 is 31, so this is 31/8 of a percent. Multiplied by 1 over 100, that becomes 31 over 800. So 31 800ths, essentially. So in the same way that's, you can actually see that it's just 3% and some change. If you take a look at the fraction there below it, 1% would be 8 over 800. 2% would be 16 over 800, 3% would be 24 over 800, and so we're just underneath that 4% with that fraction there that you see in the percent sign, 3 7/8 percent. So hopefully that makes sense to you, both in terms of how the math feels as well as the strategies that are used to come up with an answer. Let's take a moment for ourselves here. Let's clear our thoughts and be completely in the present moment now. Take some time to do that. Welcome back. Well, there are many different kinds of problems that involve percentages, but fortunately all of them can be summarized in terms of variations on a central theme. And to describe that central theme, I want to introduce 3 vocabulary terms to you here, where we talk about amount, base, and rate. Sometimes I've seen textbooks describe amount as portion, base, and rate. But those 3 things, those 3 concepts form 3 different numbers in every single percentage problem that you're working with here. And so a big part of solving these kinds of problems, especially word problems, is to be able to identify which numbers correspond to which one of those words. And once you've got that, then the problem is very, very easy. So let's take some time to figure out exactly what the amount is, the base is, and the rate is of a given problem here. Well, here is an example here. 12 miles is 20% of 60 miles. That's about the distance between Fort Collins and Denver, 60 miles there. And 12 miles, if I go 12 miles down the road, that's about 20% of, well, that is 20% of that distance. In this case, it's pretty easy to figure out what the rate is. The rate is always the percentage. Always, always, always the percentage. So finding the rate is pretty quick and easy for this one. The second thing to ask is, what are we taking the percentage of? The word of there is key. In this case, it's 20% of 60 miles. The 60 miles is the base. Lastly, the third one is sort of the answer to that question. What is 20% of 60 miles? That's the amount, sometimes described as the portion. I tend to not like the word portion as much because sometimes the portion can actually be larger than the base if the percent is above 100%. But that's how that one works here. Let's take a look at this one here as well. 14% of $600 is $84. That's true. What's the rate here? Well, again, it's the percent. That's the 14%. We are taking 14% of what? The of indicates what the base is. The base is $600. And lastly, that third number, which is the answer to the question, what is 14% of $600? That's the amount, which is $84. Lastly, 32 books out of 2,000 books is 1.6%. Once again, what's the rate? What's the amount? What's the base? The rate here, once again, is the percentage of 1.6%. It's 1.6% of what? Well, it's the 2,000 books there. So once again, that's the base. And lastly, the amount is 32 books. 32 books is 1.6% of 2,000 books. So we can see there how these numbers are being assigned to each one of these. So hopefully that's helpful to you. Let's talk about two techniques in which we can describe how to solve some of these problems once we know what the amount, base, and rate are. Once you've figured those things out, then there are two different techniques that you can utilize to solve any problems. And you can choose whichever one is best for you. My philosophy on exams is that if you get the right answer, I don't care if you got it through smoke signals or mind control or midi-chlorians, or I don't care how you solve it. However you solve it, if you get the right answer, you get full credit. It's only when you get the wrong answer that I take a look at your work to see if I can understand what you did, and if I can follow your train of thought and notice you just missed a negative sign here somewhere, then of course I give you partial credit and just take 1 or 2 points off. So here's the first of these two techniques here. I call it the proportion technique. And essentially, each time that you've got any of these problems here that involve a percentage, you set up a proportion. The proportion will, on the right-hand side, always have the percent or the rate sitting in the numerator, and the lower number on the right-hand side will always be 100. Always, 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 because the percent is always a certain number out of 100. By definition, that's what percents are. On the left-hand side, we have an amount and we have the base. So simply, that's how you build your proportion there. And so here's an example here. There's another way in which you can describe this in terms of proportions. You can say amount over base is equal to such and such percent on the right-hand side here. Just understand that that's such and such percent out of 100. So you can either say it as, in this case, well, as an example, 25%, or you can describe it as 0.25. Just understand, in order to go from something that's a percent, you've got to convert it away from being a percent, or in this case, if it's 25%, 0.25. So that's an alternate way of setting up the proportion. It's not really something that I'm a fan of, but that's nonetheless there for you. So here's an example how we would set up this proportion, and here in both instances I'm using the percent model for being able to do it here. 25% of 60 students is 15 students. We have the amount on the left, we have the base in the lower left, and we have the percent on the right-hand side here, 25%, or 25 over 100. Same thing, 25 over 100 is 25%. In the same way, $32 is 50% of $64. That's also true. So on the left-hand side, $32, the amount, over $64, the base, and that's equal to 50% on the right-hand side there, or 50 over 100. Here's another example here. What is 30% of 180? For the first time, we're not giving you all of the information, so you have to solve for something. So what is it that's been given to us? Well, obviously the rate has been given to us, 30%, that's the rate. So on the right-hand side, we have 30 over 100. On the left-hand side, we have to figure out whether or not 180 is the amount or the base. Well, 30% of what? Well, we're talking about 30% of 180, so 180 is our base, which means that our unknown is on top. Unknown is x. So what we're going to do here is we're going to cross multiply in one direction, just like before, just like we did when we were working with fractions. If those two fractions are equal to each other, then the cross multiplication is also true, that 100 times x is equal to 30 times 180. So you can see that I've written that out below there. 100 times x is equal to 30 times 180. Now I haven't gotten into yet how to solve equations, but we can at least on the right hand side there simplify that. 30 times 180 is 5400, so we've got 100x is equal to 5400. So what number times 100 gives us 5400? Well, you might already be able to discern that that number is 54. Your inner mathematician might be giving you that answer already. Another way to find it is to undo that multiplication by 100. What is the opposite of multiplication? It is division. So the opposite of multiplying by 100 is dividing by 100. So if I do that there on the left-hand side as well as on the right-hand side, that 100 disappears because I've divided it off, and on the right-hand side, 5400 divided by 100 is simply 54. Our unknown is 54. So, going back to the problem, what is 30% of 180? The answer is 54, and you got that by setting up a proportion. Here's another example. 40% of what number is 25? 40% of what number? Well, once again, probably the easiest one to discern is the rate. 40% is our percentage, so on the right-hand side, we write 40 over 100, but then we have to discern what's going on the left-hand side. 40% of what number? It's the base that we do not know this time. 40% of what number indicates that our unknown this time is in fact the base. So our x now, our unknown, should be going in that denominator where the base always goes. 40% of what number is 25? That's our amount, or a portion, that goes in the upper left there. So we have 25 over x is equal to 40 over 100. Again, we're going to do the cross multiplication here. So 40 times x on the left-hand side is equal to 25 times 100, or 2500. So we have an equation here, 40 times x equals 2500. We can figure out what x is by dividing both sides of that equation. We'll talk about this more when we start solving equations together, but dividing both sides of the equation by 40 removes that 40 from the left-hand side, so we just have an x, and on the right-hand side we now have 2500 divided by 40, which is 62.5. So let's go back to our problem here and see if that makes sense. 40% of what number is 25? Well, okay, the answer being 62.5. Well, 40% is a little less than half. Okay, so 40% of 62 is about 25. Yeah, that's about right. It's a little less than half of 62. So our answer is intuitively reasonable. Here's another example. 12.4 miles is what percent of 80 miles? Now what's our unknown? Well, in this case, the words what percent indicate that our rate this time is the thing that's unknown. So for the first time, on the right-hand side, we have an x in the upper right there. It's x over 100. The other two numbers fill up the left-hand side. 12.4 miles is what percent of 80 miles? The percent is being taken of 80 miles, so 80 miles is our base, that goes in the denominator. 12.4 miles is our amount, that goes in the numerator. So there's our proportion set up once again. We can cross multiply again, and we have 80x is equal to 12.4 times 100, or 1240. You can see here another example of how we can multiply by 100 by moving the decimal place 2 spaces to the right there. 12.4 becomes 1240. 80x equals 1240. What are we going to divide both sides of the equation by? Turns out it's 80. So that's going to remove that 80 from the left-hand side. We'll just have an x. And on the right-hand side, 1240 divided by 80 is 15.5. Again, let's check this to make sure that's intuitively reasonable. 12.4 miles is what percent of 80 miles? 15.5%. Well, that seems about right, because if it's 80 miles, then that's pretty close to 100, and 12.4 miles out of 100 would be about 12%. And so to get a number that's pretty close to 12% or 15.5%, that's pretty reasonable. So work on these on your own. Take some time to do these. Use the same procedures that we used here, and we'll check back in just a moment. Welcome back. Well, we now have 3 additional examples that hopefully you've taken some time to work out on your own with regards to how to solve problems containing percentages using this proportion method. Let's take a look at the first one. What is 82% of 250? Again, as usual, the easiest thing to pick out is the rate. That's 82%. So the right-hand side of the proportion is 82 over 100. It's 82% of what? Well, that's 250, so that's our base. On the left-hand side there, 250 is in the denominator, which means our unknown is in the numerator. If we cross-multiply those two fractions together, we get 100x is equal to 250 times 82. When we solve that equation, we get 205. That seems pretty reasonable there. 205 compared to 250, yeah, that's about 80% of 250. Let's take a look at the middle problem here. 21% of what number is 42? Again, the rate is easy to pick out, 21%, so 21 over 100 on the right-hand side. On the left-hand side, it's 21% of what number? Of what number? The base is the thing that's unknown this time, so we have an x being placed in the denominator on the left-hand side, and above that we have our amount of 42. So cross-multiplying once again, we have 21x is equal to 42 times 100. And when we solve for x there, we get x is equal to 200. Now, is that intuitively reasonable? 21% of what number is 42? Okay, so 200. 42 out of 200, yeah, that's about 21%. That makes sense. Lastly, what percent of $48 is $15? Well, once again, it's easy to see what the percent is. In this case, we don't know what it is. So the rate is on the right-hand side. The right side of the proportion is x over 100, and on the left-hand side we have 15 over 48. We cross multiply to get 48x is equal to 15 times 100. We divide both sides to get 31.25%. What percent of $48 is $15? Well, half of it would be $24, and so a quarter of that would be about $12. So yeah, $15, it's more than a quarter, less than half, 31.25%. That's a pretty reasonable answer to get. Let's take a look at the example that I gave you in the beginning here, and let's see how we could actually solve that now. Again, John, me, I had a recent purchase for which the sales tax was $16.23, where the sales tax rate was 6.25% rather. What was the amount of the full purchase? All right. Well, again, here the rate is easy to pick out at 6.25. So on the right-hand side, we have 6.25 over 100. On the left-hand side, we've got to figure out what's the amount and what's the base. Well, in this case, we're trying to find we're actually trying to find the amount of the full purchase. We actually know what the sales tax is, and we know that the rate is 6.25%. We know that that sales tax was taken of the full purchase. So it was 6.25% of something that we don't know that got us to $16.23. The fact that it's 6.25% of something we don't know tells us that it's the base that's unknown this time. So in the lower left we have an x, and above that we have our amount of $16.23. We can solve this by cross-multiplying once again. We're dividing both sides by 6.25, and we get an answer of $259.68. That's the right answer. That's what the subtotal was before adding tax. And actually we can add tax onto this to find out what the actual total was, $275.91. All right, so let's take a look at additional examples here. Buffalo, New York receives an average of 94 inches of snow each year. One year it had 120% of the normal average snowfall. How much snow did Buffalo get that year? Well, let's see. It's easy again to pick out the rate. That's 120 over 100. And in addition, I want you to notice that really for the first time we're dealing with percentages that are over 100%. That means that our amount, or our portion, quote unquote, portion, is actually going to be larger than our base. But let's figure out whether or not it's our base or our amount, which is missing here. This is 120% of what? Well, it's 120% of the average normal snowfall for Buffalo, New York. And we know what that is. That's 94 inches, so 94 inches is our base. And it's the amount that is unknown here. So we know that we're going to get an answer here, or we should get an answer here, that's above 94 inches, because we know that the amount should be bigger than the base because the percent is over 100%. So let's think about that as we're solving this proportion by cross-multiplying. 100 times x is equal to 94 times 120, or 11,280. We divide both sides by 100, and you should be able to do this without a calculator. Just move the decimal point over a couple of spaces there, and we get 112.8 inches. That is indeed above the average value. That's our base of 94 inches. So as predicted, our amount is larger than our base. We got more than the average amount of snowfall that year. We got 120% of normal, or 112.8 inches. Another example, in a recent year, the freshman class of a prestigious university had 18% Asian American students. If this represented 380 students, how many students were admitted to the freshman class? Let's round to the nearest student. We don't want to slice people in half here. So, in this case, once again, the easiest thing to pick out is the rate. All right, that's 18%. So that's 18 over 100 on the right-hand side. On the left-hand side, we've got to figure out 18% Asian American students. 18% of what? Well, that's 18% of the total number of students in the freshman class. And we don't know what that is. So our base is unknown. We place an X in the lower left. We know, however, that once we take 18% of that unknown quantity, we're going to get 380 students. 380 is our amount. So that's 380 in the upper left here. Again, we're going to cross multiply. 18x is equal to 38,000. And what we get is 2,111 students and some change. We round that to 2,111 for numbers of whole students there. So do this one on your own here. In a recent year, it was estimated that 24.7% of U.S. adults smoked tobacco products regularly. In a group of 2,000 adults, how many would be expected to be smokers? Take a moment to work on that. Welcome back. I don't know if you can tell this right now, but right now Fort Collins is getting one of its very common springtime afternoon thunderstorms. It's making a little bit of noise here, but if you hear a little bit of thunder and rainfall, that's what's happening. In a recent year, it was estimated that 24.7% of U.S. adults smoked tobacco products regularly. In a group of 2,000 adults, how many would be expected to be smokers? Well, implicitly, what we're trying to find here is what is 24.7% of 2,000 people. So we know what the rate is. It's 24.7. 24% of 2,000 people is what we're trying to find. So our base is 2,000 and our amount is X. We solve that proportion through cross multiplication and we get 494 smokers out of 2,000. Does that seem reasonable? Well, 24.7% is about a quarter or so, and out of 2,000 students, you'd expect that to be about 500 people. 500, 1,000, 1,500, 2,000. That's stepping by quarters of 2,000 there. So the fact that we got 494 makes a lot of sense. All right, so take some time to work on this one now. 8 students in a statistics class received a grade of A in the class. If this represents about 19% of the class, how many students are in the class? And again, we're not going to split people in half or otherwise. Let's round to the nearest student. Welcome back. Well, in this case, we're dealing with 19% of a class, so it's easy again to pick out what the rate is. It's 19%, so 19 over 100 is on the right-hand side. On the left-hand side, well, we have to search for what the number is. We have a number disguised as a word here. 8 students in a statistics class received a grade of A in the class. So, is 8 the amount or is it the base? Well, those 8 students represent 19% of the class. The total number of students in the class. That's actually something we don't know. That's actually what we're trying to find. So our unknown in this instance is the base. So x is in the lower left with 8 being on the top, representing the 19%. Let's solve this through cross multiplication once again, and what we can get is 42 students rounded off to the nearest student. By the way, that curly equal sign that you can see off to the side there, that's how we say approximately equal to in mathematics. All right, work on this one here now. Now in this case, you're going to see for the first time an instance in which I'm throwing more numbers at you than you actually need. And your job is to pick out which numbers, which quantities are most important and actually relevant to solving the problem here. So there were 425 donations made for various dollar amounts at an annual sanctuary. If 60 donations were made in the $100 to $199 range, what percent does this represent? And let's round to the nearest tenth of a percent. Take some time to work on that. Welcome back. Well, in this case, we have 425 donations made for various dollar amounts at an animal sanctuary. So we have a total of 425 donations, of which 60 are considered as being somewhat special. And we want to know what percent do those 60 represent. So percent is the thing we're trying to find, so our rate is the unknown. So we have an x over 100 on the right-hand side. And we are wondering what percent that is of. We don't know what the percent is, but we know that it's of the total number of donations. So it's of the 425 donations. 425 must be our base. And then lastly, we know that whatever percent it is, it's whatever 60 out of 425 is. So 60 is our amount. Notice that there are some numbers there that we did not need to use. $100 to $199 range, that's just a label on which category we were talking about when it came to a specific subset of donations, the 60 donations in question. Well, we cross-multiplied to find out what x is, and we got 14.1%. Again, we're rounding the percentage point off to the nearest tenth of a percent, so we're allowing one decimal place. If it's If it's hundredths, it's 2 decimal places. If it's thousands, it's 3 decimal places, and so on. There's a lot of problems in the MyMathLab homework that watch whether or not you're rounding the answer correctly. And I've seen a lot of students get frustrated because they know they have the right answer, but as it turns out, it's looking for a number correctly rounded to to an absolute decimal place. And so keep that in mind. If you're sure in MyMathLab that you're entering in the right answer, check to see in the instructions what exactly they want you to round that answer to. And I think you'll find that oftentimes that's the source of the issue here. All right, so that's the proportion method. That's the first of the 2 methods that I wanted to show you. Here's the other method, which I sometimes call percent equations. And to do this method, you basically each time draw a circle, and in the upper part of the circle, you place a P, you have a line across the middle of the circle, and you divide the bottom part of the circle with an R on the left and a B on the right. This P and R and B represent the same vocabulary terms that we learned earlier in the video here. Amount, or portion, I'm going to say portion this time, P for portion, then rate and base on the bottom. And so here's how we generally do this here. When we are solving for a portion, we're solving for the portion, for the variable that is in the upper half here. So we're going to use the bottom 2 variables in order to solve for that portion. So it's R times B. So we put a multiplication sign between those 2 things. We know that we have to multiply rate times base. And in this case, it's rate expressed as a non-percentage. I cannot stress this enough. In our previous methodology where we used proportions, we were describing the rate as a percentage. Here you're describing it as a non-percentage. So instead of saying 18%, we say 0.18. We make that conversion to describing the percentage as a non-percentage. You can either describe it as a decimal or a fraction, but it has to be a non-percentage. So that's what we do if we're solving for the amount or the portion. The second type of problem is where we are solving for the base, and you can see that in the far left over here with that circle. We're solving for the base there in the lower right, which means we're working with the portion or the amount and the rate in the lower left there. Portion is situated above rate, so we take portion and divide off the rate in order to get the base. So you can see there, if we want to find out what the base is, we take the portion divided by the rate and we get the base. In the same way, we can take a look at the third option here. When solving for rate, rate is now in the lower in the lower left. So on the right-hand side here, you can see portion or amount is divided by base in order to get the rate. So the situation of these 3 letters in this circle here is designed to direct you to which mathematical operation to do when solving for various things here. If you're solving for the portion on top there, or on top that direction, you're going to be multiplying rate times base. That's the first circle. The second circle shows that when you're finding base, you take portion and divide it by rate. The third circle shows that when you're finding rate, you take portion and divide it by base. That's basically the idea here. And again, rate is expressed as a non-percentage. That's very, very important. So let's show some examples of how we use this here. 20% of 400 is what number? Well, we know what the rate is. It's 20%. Again, we're going to represent that as a decimal. It's 20% of what number? So that 400 is the base. We know the rate and the base. We're trying to find the portion. So that shows us that we want to use this circle, like this. Portions on top, rate times base on bottom. So once again, we are converting that percent of 20% to a decimal 0.2, and we are multiplying that times 400, just like the diagram says. We're multiplying these 2 things together to get 80 as our answer. So let's check our answer. 20% of 400 is what number? 80. Makes sense to me. Here's another example. 20% of what number is 80? Okay, we know what the rate is. It's 20% once again, but this time it's 20% of what number? The of what number, that's the base. So our base is unknown. We're trying to find what the base is, and we have, apparently, portion and rate. So what do we do here? Now that we know that these things and we're trying to find this, we use this version of the diagram where we're trying to find base, and what we do is we take portion and divide it by rate. And again, rate is expressed as in this case, a non-percent, 0.2. So we have 80 divided by 0.2, or 400. So it's actually the reverse of the previous problem that we did here. And then lastly, 80 is what percent of 400? I think you know what percent we're going to find for this because it's the same problem really that we've been doing in two different ways beforehand. 80 is what percent? It's the rate that we're trying to find. So it's pretty easy to see which version of the diagram we're going to be using here. We are trying to find rate, so we take portion divided by base. That's 80 divided by 100, and that gives us 0.2. What is 0.2 converted to a percentage? That's 20%. So take some time to actually work on these three problems here. What is 40% of 90? 235% of 60 amounts to what number? And 80% of what number is 94? Make use of these percent equations as you go through these problems. Take some time for that now. Welcome back. Let's take a look at each one of these examples here. What is 40% of 90? We know the rate and we know the base. We're trying to find the portion. The way that we find the portion is to multiply the rate and the base together. Again, converting the rate into a non-percentage of 0.4. 90 times 0.4 is simply 36. 235% of 60 amounts to what number? Again, we know the rate and the base. We're trying to find the portion, so those two numbers simply multiply together with the percent being described as a non-percent. 2.35 times 60 is 141. Lastly, 80% of what number is 94? It's clear that this time it's the base that we're trying to find, and so the base is found by taking the portion, 94, and dividing it by the rate of 0.8 to give us 117.5. Take some time to work on these three problems, just providing some more practice for you. Welcome back. Well, hopefully these three problems were equally helpful to the previous triplet of problems that I gave you. 5.6 is 0.8% of what number? In this case, we know the rate and we know the amount. We're trying to figure out what the base is, so we take the amount and divide it by the rate. That 0.008 is 0.8% expressed as a non-percent, so we have an answer there of 700. 16.1 is what percent of 46? We're trying to find the rate this time, and so we simply take the amount or the portion of 16.1 and divide it by the base of 46, and we get 0.35, which expressed as a percent is 35%. Lastly, what percent of 150 is 213? Now think about this one. This can be a little bit trippy in that it's which one of these things is the base. The temptation might be to say that 213 is the base because it's the larger number. But when we take a look at the problem more closely, we're trying to find out what percent of $150. That of indicates that our base is 150, not 213. So instead of dividing 150 by 213, we're dividing 213 divided by 150, and our answer should give us a rate that is greater than 1 or a percentage that's larger than 100%. We have an answer of 142%. All right, let's take a look at some additional word problem examples so that we can use these techniques to more real-world type problems. Here's the first one here. 46 panthers are thought to live in Florida's Big Cypress National Preserve. This represents 53% of the panthers living in Florida. How many panthers are there in Florida? And of course, we're going to round to the nearest panther. We're not going to be slicing these panthers in half or otherwise. All right, well, once again, it's pretty easy to see that we have the rate, 53%, but that's 53% of what? It's the 50%. It's 53% of the total panthers found in Florida. That's something we don't know. So we do not know the base. We're trying to find that from the portion and the rate. And we do that by taking the portion and dividing it by the rate to give us 87 panthers. Here's another one. Football player Tom Brady of the New England Patriots led his team to numerous Super Bowl victories. For one game during the season, Brady completed 23 of 30 passes. What percent of passes did he complete? Round to the nearest tenth of a percent. Well, you see this kind of thing actually when you watch sports broadcasts all the time. There are people who are hired to calculate these percentages on a regular basis. So here's an example of definitely a real-world problem here. Brady completed 23 of 30 passes. All right, so that's our portion and our base. We're trying to find out what the rate is, and we find out what that rate is by simply dividing portion divided by base for 0.76 repeating, or 76.7%, and we're rounding that to the nearest tenth of a percent, which means that our last decimal point there, we're rounding up to 76.7%. One last example, on April 20th, 2010, an explosion occurred on an offshore oil rig in the Gulf of Mexico. The explosion left 11 crew members dead and an uncontained oil leak that threatened the ecosystem in the Gulf of Mexico and surrounding beaches. The United States consumes approximately 20 million barrels of oil each day. If the oil obtained from the Gulf of Mexico represents 8% of U.S. daily consumption, how much oil does the United States produce from the Gulf of Mexico? Okay, well, once again, our rate is pretty apparent there. It's 8%, and it's 8% of our U.S. daily consumption, which we know, that's 20 million barrels. Okay, so we know our base, we know our rate, we're trying to find our portion, so that's a multiplication problem. That's our 8% there is 0.08 multiplied by 8 million barrels, that's our base, to get our amount of 640,000 barrels that we're getting from that particular site in the Gulf of Mexico. Here's some problems to work out on by yourself. Brianna read 143 pages in a book. If this represents 22% of the book, how many pages are in the book? Take some time to work on that. Welcome back. We once again have a rate and an amount, or a portion rather. So we find our base by taking the portion and dividing it by our rate to get 650 pages. That's our base. And here's another one. Hector had $60 in his wallet to take himself and a date to dinner and a movie. If he spent $28 on dinner and $19 on the movie, what percent of his money did he spend? Again, we're going to be rounding, in this case, the nearest tenth of a percent. Take some time to do that. Welcome back. Well, here's a problem in which you might first ask the question, where did you get the 47 from? That's $28 spent on dinner, added to $19 spent on the movie for a total of $47. That's $47 being spent out of the total in his wallet, which is $60. We're trying to find the percent. We're trying to find the rate, which is 47 divided by 60, or 0.783, which is 78.3%. Lastly, in a science class, 85% of the students passed the class. If there were 40 people in the class, how many pass? Take some time to do this. Welcome back. Well, here's another problem in which we are trying to find the portion. We have the rate of 85%. That's 85% of a total of 40 people in the class. We're attempting to find the portion by multiplying those two things, 40 people times 0.85, which gives us 34 people who passed the class out of 40 people. All right, well, we've reached the end of this particular video here, so take some time to go through your activity sheet and attempt to ascertain which things are the most important. What are the key concepts that we covered in this video? Take some time to actually think about that. What are some things that we covered? Well, we covered two techniques for solving these kinds of problems that involve percents. We covered a proportion technique, didn't we? We also covered a what I call a percent equation technique that involves those circles with the P and the R and the B in them. We also had three vocabulary terms that we covered, perhaps once again, the portion or the amount and the rate and the base. All three of those things, all three of those categories apply to all the problems that we were working with. So my question to you is, would a person who is taking a look at your activity sheet be able to ascertain very quickly what things are the most important? Would you be able to study this very quickly to be able to say, okay, that's what's important here, that's what's important here, that's what's important here, next? This can make your studying, in particular for your final exam, very quick and very easy because it summarizes the important things of each particular video. So take some time to do that, and I'll see you in the next video.